Morning, gents. Sorry I could not be at school today, so I'm going to go through the examples that I would have done in class. So let's have a look at this question. This should be in the handout that I gave you last lesson. So just past exam questions. So in a cricket game, a batsman hits the ball at an angle of 30 degrees at a speed of 20 meters per second. So I'm going to resolve it into the vertical and horizontal components straight away. So 20 meters per second. This is going to be 20 cos 30, which is 17.32, and this is going to be 20 sine 30, which is 10. So now we know the horizontal and vertical components. Now find the maximum height reached. So we can talk about the vertical motion here. So let's write down vertical. Initial vertical speed is 10 meters per second, taking the up as the positive direction. Acceleration in the vertical direction is negative 9.8. Now at maximum height, the final vertical speed will be 0. And we can use the UVATs to find our displacement when that final velocity becomes 0. So doing that, you will get S equals 5.1 meters. Alternatively, you can also use that formula for the maximum height, which is U sine theta squared over 2g. I'm doing it both ways, so you know that there is another way to do this question as well. So you put the value of u, which is 20, theta is 30 degrees, and 2 times 9.8, and it will also give you 5.1 meters. The points to remember here are you choose the vertical motion, and at maximum height, the vertical velocity becomes 0. Let's now move on to the second part of this question. Later, the batsman hits the ball exactly the same way on a smaller playing area, and it strikes a vertical board which is 26 meters away from him. How far above the ground H does the ball strike? Now, so this was the starting position. Isn't that the displacement basically from the starting position? So we are looking at the displacement. And which direction is the displacement in? Vertical. So that means we need to find in the vertical direction the displacement. Now let's have a look at the vertical and horizontal components. So initial vertical velocity was 10, acceleration is negative 9.8, but we need 3 things to find one unknown. So let's first use the horizontal motion to find the time taken. Now there's only one formula in the horizontal motion. Distance traveled is the horizontal speed times time, and you must know horizontal speed remains constant throughout the motion. So we know that it has traveled 26 meters horizontally. Initial horizontal speed is here, 17.32. Using that, you can actually find the time taken by the ball to hit the board, which I've calculated, and it is 1.5 seconds. So you now know that the time taken is 1.5 seconds. So you can use that here and find the vertical displacement in that time. So I'll use S equals ut plus half at squared. So 10 times 1.5 plus half times negative 9.8 times 1.5 squared. And that comes out to be 3.98 meters. So we can say that the ball hits the board 4 meters above. And that's it. So the first question was pretty straightforward. In the second one, you use the horizontal motion to find the time taken to hit the board, and we use the vertical then to find the displacement, because we can see that H here is actually the displacement from the starting position. Okay, now let's move on to this one. So this is a different one because the ball is not landing at the same height. So this is the original position and the ball does not land here. It actually lands below starting height. So let's find the time taken for the stone to reach the sea. So let's deal with the vertical motion. Again, let's find the horizontal component. So 20 cos 30, which is 17.32, and this will be 20 sine 30, which will be 10. So vertical motion, the initial speed is positive 10, taking upward as the positive direction. Acceleration is negative 9.8 because it's a projectile. And what is the displacement that has happened in that time? Can you see that from the starting to the ending, the ball has gone, a stone has gone down 15 meters. So the displacement is negative 15. So it is 15, but in the negative direction. So basically you need to find t now. Now, if I use this formula straight away, s equals ut plus half ad squared, t is unknown and u is in 0, so you're going to get a quadratic. Now, you don't have a CAS in physics to solve that quadratic, so we need to do something else first. Let's use the vertical motion to find a velocity, final velocity when it hits the ground. So let's use this formula to find the final velocity. So the vertical initial is 10, A is 9.8, and S is negative 15. So you get V equals 19.85. Now, you know that the ball is falling down when it hits the water. So stone, sorry, not a ball. So the final velocity will be negative 19.85. And remember, we found velocity because to find time using s equals ut plus half at squared, we got a quadratic and we don't need that. Now that we have V, I'm going to use this equation to find our t. So t is v minus u over a. So the final vertical speed is negative 19.85 minus u. U is 10 and acceleration is negative 9.8. Using that, I'll get time equals 3 seconds. And that is our answer. Now, we need to find the magnitude and direction of the velocity as it reaches the sea. Remember, at any given position, the velocity is the resultant of the horizontal and the vertical components. We've just found here that the vertical velocity is 19.85 downwards when it hits. Horizontal stays constant throughout. So what was the horizontal component to begin with? 17.32 to the right. So we now need to find the resultant. So we can see the resultant is square root of 17.32 squared plus 19.85 squared, which is 26.34 meters per second. You also need to find that angle, and we can see that tan of this angle is equal to 19.85 over 17.32. So theta will be tan inverse of that, and that comes out to be 49 degrees. So the velocity is 26.34 meters per second, and theta is 49 degrees. We don't have to specify it's below the horizontal because it's already asked. The question's already asked, find the angle between the velocity and the horizontal, which is theta. Okay, I'm going to stop this video here and do another one for the next question.